In this video, we're going to integrate this particular integral here using integration by parts. You can work it another way. Go ahead. You might consider partial fractions if you didn't have that e to the x there. Integration by parts should work here. So the formula for integration by parts, at least one form of it, looks like this. Want the integral of u dv, and then the answer, the first part of the answer will be the product of u and v, and then minus the integral of v du. So what we have to do then is break up this integrand into two parts. One we're going to differentiate, and the other one we're going to integrate. So we can consider, say, the x, e to the x, as one part by itself, and the other one could be 1 over x plus 1 to the second power. You can integrate x e to the x, and you can differentiate it. The same thing for the second part, 1 over x plus 1 to the second. The problem here, though, is that x e to the x, to integrate it, you have to use integration by parts. So I choose to differentiate that part, x e to the x, and I'm going to differentiate the 1 over x plus 1 to the second. So du, have to use the product rule here. So x times the derivative of e to the x is e to the x, and then it's plus the e to the x times the derivative of x, which is 1, so it should be e to the x, and this will be dx here. Now for this one here, this is dv here. I'll put a dx here because I'm going to integrate here with respect to v on the left side, with respect to x on the right side. And this is no different than if you have something like 1 over x. You can write that as x to the negative 1. Then if you integrate this, and I guess I should make this a 2 here. So if we integrate it, we add 1 to the negative 2, we get negative 1. And then we divide the coefficient by negative 1, so this comes out to a negative. So the integral of 1 over x squared, or x to the negative 2, is negative 1, x to the negative 1. Do the same thing here. You could use a u substitution that let u equal to x plus 1, but then du would be just 1. So it's the same thing then. I could just do it this way and rewrite it as x plus 1 to the negative 2, and then integrate. V would equal 2. Add 1 to this exponent. Give me x plus y, or x plus 1 to the negative 1. And then I divide the coefficient 1 by negative 1. I get negative 1 out here. And then I'll rewrite this as negative 1 and take this to the denominator, change the sign. This will be x plus 1. Okay, so now I can get this out of the way here. So now we're set here. Once we have our selections here, we find u and then find du, set something equal to dv, and then integrate, we get v. Then the formula for integration by parts tells you that the first part of the answer is the u times the v. So it's this times this. Negative 1 multiplies x e to the x, so I'll just put the negative here. It'll be negative x e to the x over x plus 1. Okay, this is your uv in the formula. And then it has a minus, and then integral, and then the next term here should be a v. So v is this right here. All right, negative 1 over x plus 1. That's the v. And then it's du, put that in parentheses, du is going to be all of this right here. Looking ahead here, I'm going to factor an e to the x out of this. So it's going to be e to the x. Taking out the e to the x, leaving with x plus 1. And then I got the dx over here. And so notice here, got a factor of x plus 1 here and here. Those divide out, and I have a double negative here, minus and a minus. So the first expression stays the same. I got minus x e to the x over x plus 1. Because of the double negative, this becomes a plus the integral. And all I have here then is e to the x dx. And the integral of e to the x with respect to x is e to the x. So this is equal to minus x e to the x over x plus 1. That doesn't change. And the integral of e to the x, we said, is e to the x plus your constant of integration. And that's the answer actually. But you might see some textbooks simplifying this, so they get the common denominator, which is x plus 1, and combine. So let's just do this. I'm going to put everything over x plus 1. So I got x plus 1 here, the denominator. That's minus x e to the x. And then I multiply the e to the x numerator and denominator by x plus 1 to get the same denominator there. And then multiply e to the x times the x plus 1. That gives me then an x e to the x plus e to the x. Got the constant of integration there. And then we just combine terms here. Minus x e to the x and x e to the x, those cancel out. So I'm left with e to the x over x plus 1. So let me just cancel these out. So these cancel out. And I'm simply left then with e to the x over x plus 1 plus the constant of integration. Thanks for watching. We'll see you next time.